Assalamualaikum. My name is Muhammad Fathurrahman bin Rustam. My number is DE190162. I'm from group 34, which is for the lab 1, label power engineering laboratory 1, section 6. Okay, I represent for our group to explain about for the introduction to LVSB design, low voltage switchboard. Okay, so now I'm represent to explain about the task for video, which is the number 1 for the switchboard panel with a complete explanation of the component, which is I will explain what the function of the component in the switchboard panel. Okay, firstly, okay, let me show the figure for the switchboard panel with complete component. Okay, as a label, I will zoom in. Okay, you can see for the switchboard contains two set at the lab. Okay, so the firstly we call is the kilowatt hour meter. We use this for to measure the amount of electric energy that used by the machine or device that we as the measurement. Okay, then for the indicator light, okay, it has contain main supply and bus bar supply, which is it will light on when it will show us to indicate the input and output of the circuit at the function or not function. Okay, then for the heater panel is the indicator and the heater switch off and on, and it will give us to control the moisturize on the circuit. Okay, as a heater element to heat up the circuit. Okay, and then air circuit breaker. Okay, this is a lock. Okay, the air circuit breaker is to distribute the electric energy and protects the lines and power supply equipment from overload and short circuit. So it will protect, which it will if happen some short circuit, it will completely break down and cut off the circuit. Okay, then the overcurrent and fault relay. Okay, the to monitor and detect overcurrent on individual phases and non-directional fault. Okay, it will use for the three-phase application. Okay, so overcurrent and a fault relay will be use this components. Okay, and then the emitter. Emitter is always for the reading, which is we measure the current that is passing through the circuit. So the reading we record in the table as our result. And then for the meter and power factor, for the power factor meter, which is we use the analog, is shown the indicator, not the reading. Okay, to determine the type of load and calculate the losses on the load. That's for the power meter analog type. Okay, it's that's digital. We use the analog. Okay, and then for the voltmeter, it will use to measure the voltage or potential difference between 2 points in an electrical circuit. Okay, and then a fault relay, we will use to detect the voltage on the metal enclosure of electrical equipment and interrupt the circuit if voltage is detected. A fault relay, we cut the if the voltage is detected. And then lastly, a leakage relay. Okay, this the figure to sense a leakage and open a circuit breaker when the leakage current exceed the preset value. Okay, that's all for the component on the switchboard panel. That's all from me. Thank you.
Okay, Assalamualaikum. My name is Muhamad Haiqal Najmi, and I will proceed with the figure 7.3 schematic control diagram for main incoming. Alright, so first of all, we need to know that the incoming supply and the outgoing. Alright, so for the incoming supply from the TMB, we got this here. It is from the TMB at the bottom of the schematic, and also for the outgoing, we got this bus bar at the top of the schematic. Alright, so let look for the first one. Okay, so as we all know, it is for the AC supply because we got this it is show that this is the AC supply, and then we got 1 2 3 4. Okay, 4 is mean that it has 3 phase to single phase, and we got the 3 line because of it is 3 phase to single phase. Okay, So how do you know it is the three phase? Alright, so here we look at here. So this is the red current, the red cable, because of this the label is R. Alright, so this is the Y because of the label is Y, and this is blue because of the label is B, and then the last one is E. It is neutral, and then it connect to the ground. Alright, so this cable will connect to the kilowatt hour meter. Okay, so beside that, okay, so this is in the middle, it is the contactor here, and the beside of the contactor is the labeling for kilowatt. Okay, so we'll connect to the kilowatt. Okay, same goes to this, right? So we can see here that 40 and 100 is labeling for the kilowatt per hour. Okay, so this one is a MCB here. MCB stand for minimal circuit breaker for protection. Okay, so alright, so we got the top. Okay, we got this MCB, and also we got the main supply indicator. Okay, so main supply indicator is the function for the main supply indicator is we can see either the incoming from TMB. Okay, we can see from the main supply indicator. Okay, when the incoming go to the main supply indicator, then the RYB light was it is in turn on. Okay, it will be turned on. Okay, so alright, top of the main supply is the heater, so we can control the heater because it cannot has a moisture here. Okay, so alright, this one is the ACB, stand for air circuit breaker. Okay, he got three phase here, and it will connect to the relay. Okay, here it is the relay, and also this air circuit breaker is related to Fox. Okay, alright, so for the relay is it will step down to 5 amp because of it cannot reach the high current. Okay, so here it is the CP. Okay, we got this CP. Okay, so for the CP has 4 unit. Okay, based on this number. Okay, 4, so it is 4 CP, 4 unit. Okay, it also connect to the relay here, and for the ratio, okay, this ratio, okay, the number of ratio, so for the number of the ratio, it is show because of it connect to the voltage. Okay, so it will show the ratio here, and this one it is the AC, stand for current emitter and selector switch. Okay, so we can change, we can select manual the RYB value here, and this one is stand for the voltmeter selector switch. Okay, VS. Okay, here, and this is for the, okay, this is the bus bar indicator light. Alright, so the last one is the outgoing bus bar. Alright, so that's all for the 7.3 schematic diagram.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. So my name is Muhamad Akmal bin Ridzuan, and my metric ID is AA190023. So for today's experiment, which is experiment number 4, introduction to LVSB for subject BEV 30401, Power Engineering Laboratory, I will do a presentation about the LVSB design. So as you can see, today I will do an explanation about how we want to read the schematic diagram for the fault relay. So firstly, we must know that the input is always starting from the below part of the diagram, which is, you can see, this is the incoming from the main bus. You can see this is the input AC supplies, and then we have 4 wire, which is red, yellow, blue, and the neutral one. And as you can see, this is the earth fault relay. This has 8 label. So label number 1 and number 8 is connected to the red wire and the neutral one. So it is used to energize the earth fault relay. So label number 3 and 4 is connected to the coil in the earth fault relay to give the signal to the earth fault relay. So as you can see, the number 3 wire label number 3 is connected to the wire label number 1, which is the red wire, and number 4 is connected to the neutral one. So in the label number 4, there is a shunt triple coil which is connected to the TPN MCCB, which is the circuit breaker. So as you can see in this coil, if the coil is not connected, there will be no short circuit. However, if the coil is in the closed position, which means that the coil is connected, the short circuit will occur as a protection for the circuit. Okay, so as you can see, this is the current transformer. Which means that the input current that will always enter through the wire label number 7 and number 2 will always be 5 ampere. Okay, now we move into the next figure, which is figure 7.5 for the schematic control diagram for outgoing feeder leakage relay. So as you can see, as always we must read from the below part, which is at the okay. So the circuit have 4 wire, which is the red wire, yellow wire, blue wire, and the neutral one. So as you can see, first we must have the incoming supply, AC supply from the main bus bar. So this is the AC supply, the input AC supply. So next, and then as you can see, this is the earth leakage relay. Wire label number 7 and number 9 is connected to the red wire and the neutral one to energize the relay. And then the number 12, wire label number 12 and 10 is connected to the coil in the earth leakage relay. And then we have the shunt trip coil that is connected to the TPN MCCB, which is the circuit breaker. So as you can see, the coil in the earth leakage relay is in open position, which means that it is not connected. So as the coil in the earth leakage relay is in the closed position, which is connected, the shunt trip coil will send a signal to the TPN MCCB to do a short circuit to act as a protection for the circuit. So as you can see, this is the ZCT, or the zero current transformer, which means that there is a looping over here, and that is connected to the wire label number 1 and number 2 on the earth leakage relay. And then as you can see, the circuit continue to connected to the load. So that's all for me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.